Well, the new Flukes came in tonight, and they're brand new in original factory boxes. We're opening up one. We're going to give it a test as soon as we can. There we got the manual. The desiccant. Good thing. Oh, that's a nice amount of desiccant. Great they used it. I'm not sure how long it's been in here. My guess is it's probably been in here for close to 35 years, something like that. Let's see, 1979 was the revision on this book. 1982. Copyright 1982 John Fluke. So I'm going to guess this was in 1982. So 82 would be 30 years ago. So it's 30 years old. Test leads. Power cord. I'm going to set this down and allow myself to pull it out. Well, just a couple of minutes ago, I opened this box back there and removed this manual, set of test leads, power cord, extra fuse, and this beautiful Fluke 8000A that has never been used since it was packaged at the factory and set up here on my bench right now. So it's been about 30 years, so no kidding you, it's old stock, but it's as far as having ever been used, it has never been used. It's brand new old stock. This 30 years ago was was at the top. This was the hot machine. I had one of these in my instrumentation test lab in emissions for Chrysler back in the 80s. And we used it to calibrate all of our equipment. And I've always wanted one of these. I now, at the moment, own 4 of them, brand new, never used. And we're going to give this thing a little test here to see how it's fared holding up over these past 30 years. Okay, we're going to have a little fun with the voltage here. I'm going to use the voltage reference and step up the voltages on each of the digits. Right now we're at 1 millivolt. There's 2, 3, 4, 5, 6, 7, 8, 9. Let's go to the 100th of a volt. 1, 2, 3, 4, 5, 6, 7, 8, 9. And to the 10th of a volt. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the 1 volt. 1. Okay. Let's go ahead and go to the 200 millivolt range. I think I got us zeroed there. And then let's go ahead and we're going to go with a 1/10 of a millivolt, just 2/10. 3, 4, 5. So we're a 1/10 high. 6, 7, 8, 9. So we're reading 1/10 of a millivolt high. Now we'll go to the millivolts. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go to the 100th of a volt. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and to the 10th of a volt, there's 1. So you're at 100 millivolts right there, and we are reading 100.0 up on the B&K, and the Radio Shack is reading 100.6. So the Radio Shack is a little bit high. Maybe I'll get a chance to calibrate it somewhere along the way. Let's go ahead and let's kick this thing up to the 20 volt range, and we'll go with the volt step. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then go ahead and change to the 200 volt step, we see 10, and the 1200 volt step, we see 10. And we are reading 10.002 on the B&K. So my guess is this thing is extremely accurate, as we proved earlier. And you got to see the fun of watching the digits light up one step at a time. I find that remarkable. Okay, I think we've made a point here. Let's move on. Okay, what we've done is we've set a signal generator up, and we're feeding in a 60 hertz signal right now, roughly 200 millivolts, and we're reading it on the Fluke, we're reading it on the Radio Shack, and we are reading it on a B&K 4.5 digit. Now, truth be known, I can't tell you positively which of these devices is accurate. I haven't had either one of them calibrated at a standards lab for AC. However, if we take a look at the readings, we see that the Fluke is reading 199.2 or 3, flashing between 2 and 3. The B&K is reading 199.56, so we could say 199.5, maybe 199.6, and the B&K 198.7. I mean the Radio Shack is 198.7. Now, if we were to take the B&K as the standard, 4.5 digit, and we're only really using 3.5 of them. So if we went and said that it's 199.6 volts is accurate, and our reading here is 199.3, 2 or 3, we'll go 2. 199.2 divided by 199.6 minus minus 100%, minus 1, is a 0.2% difference. So if the B&K is accurate, then we are different than the B&K by 0.2%. If somehow by a miracle of fate the Radio Shack was accurate, what would we be? 199.2 divided by 198.6, and then subtract 1, and we are 0.3% different. So we agree on all 3 meters to within 0.3% at 200 millivolts AC at this frequency. And the rating on the on the meter is indicated underneath itself, and it is rated AC volts plus or minus 0.5%. So if we are within 0.3% on all three of these meters, and if we assume that at least one of them is accurate, then we are well within the 0.5%. And that's really all I wanted to prove, is that we seem to be within our specified rating. Let's go ahead and kick ourselves up to a different scale. And let's try upping the voltage out of the generator to about 1.9 if we can get there. Alright. It's pretty close. We got 1.98 on the Fluke. Let's try and kill this lamp here. 198.2 on the Fluke. Now we have 197.2, and we have 198.3. Is there anything we can do about that? Glare. .3.4, 198.2, or 1.982, 1.974. So on this scale, 2-volt scale, if the B and K is correct, then we are 1.982 divided by 1.984 minus 1. We are 0.1% off. One-tenth of a percent. If the Radio Shack, again, by some miracle of fate, the Radio Shack was correct, then we have a 1.982 divided by 1.974. Subtract 1, and we are 0.4% off. Still within the 0.5% on the 2-volt range. If we go to the 20-volt range, and we'll take ourselves up whatever we can get. Looks like I can get 10.37. So we get 10.37 on the Fluke. We've got 10.376 on the B&K. And we have 10.29 on the Radio Shack. Well, something tells me here we're going to come out pretty doggone good. So if the B&K is right, then we've got 10.36 divided by 10.37, subtract 1. We are 0.096, so 0.1%. If the Radio Shack is correct, we are 0.6% off. So if the Radio Shack is right, then we are a little bit out of our spec. However, I gotta believe this B&K, which is a 4.5-digit meter, and this 3.5-digit meter, which are within 1/100th of a volt, I bet they're both tracking each other correctly. My Radio Shack is probably a little flaky. I don't know, we can go to the 200 range. I can't give you any more voltage out of the generator. However, we're at 10.3 here, and we are at 10.37 up here. 10.3731, 10.375, 10.37 it appears to be. And here we are at 10.3. Well, I've been watching this Fluke vary between 10.3 and 10.4. And the B&K has given me 10.37 as a reading. 3.7 and a little bit more. So it's quite possible that the 3.7 is here because I'm bouncing between 0.3 and 0.4. Hard to say. We don't have enough digits to tell, but I'm quite happy with the response on this. It's reading quite well. We're going to go ahead and check resistance. Okay, we've got ourselves set up to measure resistance right now with the Fluke, and we have a 10K 0.1% resistor, precision resistor that we're measuring, and we are on the 20,000 ohm scale. This is a 10K resistor. We are reading 10.01, and the 1 is flashing. So a 0.1% resistor would read 0.01 at maximum off. So we got it nailed. Let's go ahead and take a look at another resistor. This is a 100,000 ohms at 0.1. I'm going to have to set you down a second. Okay, change our scale. And we are reading 100.2. Flashing between 0.1 and 0.2. This is a 100K 0.1% resistor. So 0.1% resistor at 100K would be 0.1 maximum off, and we are 0.1 with a digit maybe. The resistance scale is 0.2% of input, so 0.1% for the resistor, 0.2% on the scale. We are within the specifications. All right, let's try a 1 meg resistor. Hang on a sec. Okay, we have a 1 meg ohm 1% resistor here. 1% of a million ohms would be 10,000 ohms, and we are reading about 1,001,000, 0 to 1,000. So we are within the 1% and we are reading it accurately. Let's take a look at the next resistor. Okay, we have a 10 meg ohm resistor, 1%, and we are reading 10.04 on the meter right now. 1% would have put us at 10.1, so we are within the 1% value, and we're getting a good reading. So there we go. Our resistance scales measured very well from 10,000 ohms up to 10 megohms. Nailed it. All right, at this moment, we have the DC milliamp function punched in. We're hooked up to measure milliamps right now. We are on the 200 microamp scale. And what we have is we have a voltmeter, a power supply. This power supply is feeding voltage through this line into this resistor. I'm monitoring the voltage drop across the resistor with my B&K meter up here. And right now we have 1.804 volts. And then I am taking the current from the resistor, feeding it into the meter, then out of the meter, and back to the power supply again. So I've got a resistor in series with the power supply and the meter is essentially what's happening, and I'm measuring the voltage drop across the resistor. This resistor happens to be a 100 kilo ohm, 1/10 of 1% precision resistor. So I know with some certainty that that's 100,000 ohms. And right now we are reading, again, 1.804. So if I am 1.804 volts divided by 100,000, then I am reading 0.018 amps. And I am reading 0.018 amps with just a little bit more. Voltage is 1.8195. Alright, let's take another look here. We got 0.0182. 0.0182, 18.2 microamps. And we are reading, well, it was voltage, so what can you do? So we determined that that current is being read very accurately. 18.2 microamps is what we expected. Let's go ahead and change the voltage drop. 10 volts. Pretty close to 10 volts, 0.9997. And I'm reading 100.8 or 9 microamps. Let's take a look at this. If we are 9.996 volts divided by 100, 123, we are going to read 0.09996 or 0.1, 100. We are reading 100.8 or 9. That would be 0.8 microamps. We're accurate. Let's try this one more time. No. We are 9.996 divided by 100, 123, and that is 0.09996, or in other words, 0.1. And we are 100.1009. So we are off maybe 0.8 of a microamp. Pretty negligible amount. Okay, we're done with the current on the DC scale. And that concludes it. We have an excellent Fluke. Now, I did leave the protective plastic film on the lens. I haven't peeled it off. I'm going to leave that for the buyer. But the meter itself is an absolutely exquisite shape, has never been used other than for this calibration check, which is something that needed to happen after 30-some years. But beautiful meter. It'll be packaged in the original box along with an extra set of fuses, the test leads, the power cord, and the manual. The manual is an excellent manual that goes into detail about the theory of operation, takes you through the block diagrams, gives you the schematics, takes you through the calibrations, how to perform the calibrations. So when you get this meter, you're not going to be left hanging out there dependent on somebody else to check this thing out. Should be able to do it yourself with some just sensible by sensible means. So good luck, and I hope you enjoy the meter. Thank you.